Hello everyone, and welcome to the first video for the 3.4 notes, where we are continuing our discussion of dividing polynomials, but this time we're going to use what we've learned before of doing this, especially synthetic division, in order to find the zeros of polynomials, and also that basically comes in line with this idea of needing to factor the polynomials. A polynomial that by the means that we've learned up to now would be impossible to factor. We will see how to factor it now by using synthetic division. But anyways, without further ado, let's take a look at this thing. It's a theorem here that's called the rational zero theorem. And if you can recall, a rational number, which it gets a special name of this set, is called boldface Q, like this one. This is a set of all rational numbers. These are all the numbers that you can write as a fraction, basically like a divided by b. Such that we need that a and b are integers, which of course integers are whole numbers, both positive or negative. Whole numbers are integers. And so this is what rational numbers look like. And so it turns out that this set of rational numbers, it's of course all of the integers, like basically everything up until 0 coming from the negative side. And then continuing like this, also all the fractions like 1/2, 1/3, 3/4, stuff like this. It's possible to list all of them. Funnily enough, it is possible to organize this list so that we could list every rational number that there is. But these are all the ones that are rational. Of course, these kind of fractions, we want positive or negative versions of these. And the idea with the rational zero theorem is that it's possible to tell what are basically the candidates of rational zeros for a polynomial. And this statement for this theorem, it goes both ways. What it's saying is that if you have a polynomial like this one, like f of x written in this kind of a standard form, the way that we saw before, the strict kind of a definition of a polynomial, written in standard form here with these coefficients and x raised to different powers. If there's a rational zero of this, if there's a zero that's either a fraction or a whole number, then we could write that zero like p over q, and it would be a fact that the numerator of that rational zero, the numerator there, would be a factor of this constant term that's at the very end of the polynomial, and the denominator of that rational zero would be a factor of the first coefficient, the coefficient in the leading term there for this one. And it goes the other way, that basically if we come up with a list of all of the factors of the last term divided by all the factors of that first coefficient there, then we would come up with all of the possible rational zeros. It might be the case that none of them are zeros, or it might be the case that we have them all listed there, but it at least will give us a place to start where we can start trying to do synthetic division. This is how we would choose which numbers to try in the synthetic division until we start getting a remainder of 0, and then we will find a factor that way. And so I hope that that gives you a general idea of what we're going to do, but we can just try one right here. And so based on this rational zero theorem, what we have, this number 4, that's the coefficient of the leading term, this is that thing like a sub n that we have over here. And then this number at the end, the negative 15, this corresponds to this a sub 0 over here. And so these rational zeros that are possible, they will take the form like p over q, where this numerator should be a factor of the number a sub 0, I mean to say a factor of a sub 0, which is negative 15. And then the numbers q that could be on bottom of this one, they are all factors of our number a sub n, which in this case was 4. And so why don't we just list those, and then we can come up with all of the possible zeros. So the factors of negative 15, and here it doesn't really matter if we say negative or positive 15. I'm actually going to only list positive factors. And then whenever we list which zeros are possible, we can just put plus or minus in front of all of those zeros. So the factors of 15, what numbers can we multiply together to get 15? We can multiply 1 times 15, so 1 and 15, those are both factors of negative 15. What about also, it goes 3 times 5, so 3 and 5 are both factors. And are there any other things you can multiply and get 15? No, there are not. What about the factors of 4? We have 1 times 4, so 1 and 4 are both factors, and then 2 times 2. So 2 is a factor, and that's all of those. Now, when we come up with our list of possible zeros, there can tend to be a lot of these. It depends how many factors. These ones are pretty manageable, having 4 factors for the numerator and 4 factors possible for the denominator. It's not too out of hand. There can tend to be very many of them for some problems, but we'll mostly see examples where it's pretty manageable, the number of possible zeros. So if you think about it, we should be able to make all the different fractions that are possible by having plus or minus of having any of these factors on top, like 1, 3, 5, or 15 on top, or having 1, 2, or 4 on bottom. And so this is not a very maybe principled way of writing this one, but we will go based on this kind of a format that we have right here to try to make some different zeros. So obviously you can put the 1 over 1 is just 1, so plus or minus 1. Also 1 divided by 2, so we get a plus or minus 1/2 is possible. And the 1 over the 4, so plus or minus 1/4. These are the possible zeros that have a numerator of 1. Then we can do the same thing with 3. 3 over 1, 3 over 2, and 3 over 4. Those are possible. And so 3 over 1, of course, is just 3. And also 3/2, and also 3/4. And then we can put 5 over all of these denominators, so we can have plus or minus 5 whenever we go divided by 1. Also plus or minus 5/2, and plus or minus 5/4. And then lastly, we can use 15 as a numerator, where we can have plus or minus, if we go divided by 1, plus or minus 15. Also plus or minus 15/2, and plus or minus 15/4. These are all the possible zeros. And here we did not happen to duplicate any. Sometimes you have to be careful that choosing a different numerator and denominator pair actually ends up giving you the same zero. But we did not have that in this case. And so that's how you will find the possible zeros. In the next video here, we actually will use this technique of finding the zeros that are possible and then using those for synthetic division, seeing which ones give a remainder of 0, and that will help us to find the zeros. And we will do that in the next video. So thank you guys for watching, and I'll catch you in the next one.